In this episode, we're going to make network segmentation feel like a clear, practical concept that a QSA can evaluate confidently, rather than a confusing technical maze. Beginners often hear that segmentation can shrink scope dramatically, and that is true, but it can also create false confidence if people assume segmentation exists just because someone says the networks are separate. The reason this topic matters is that segmentation is one of the main tools organizations use to limit what is inside the cardholder data environment, CDE, and that directly affects how much evidence you need, how many systems are in play, and how complex the assessment becomes. When segmentation is real and effective, it reduces risk and makes compliance work more focused. When segmentation is weak or misunderstood, it can hide pathways that allow systems outside the CDE to impact systems inside it, which undermines the whole scoping story. By the end, you should understand what segmentation is trying to accomplish, how it shrinks scope, and how a QSA thinks about validating it without getting lost in implementation details. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The first step is understanding that segmentation is about controlling access and influence, not just drawing lines on a diagram. In simple terms, segmentation means separating networks or systems so that one part cannot freely communicate with another part. In the PCI world, the goal is usually to separate the CDE from the rest of the corporate environment so that only explicitly allowed connections exist. This separation matters because systems that can connect into the CDE or that can control it administratively often become part of scope, even if they never store card data. If segmentation blocks those paths, then those outside systems may not be able to impact CDE security, which can justify excluding them from scope. That is where the dramatic scope reduction comes from. Because instead of assessing a whole company network, you might assess a smaller, tightly controlled portion. Beginners sometimes think segmentation is a security magic trick that automatically fixes everything, but it is really a disciplined design choice that must be enforced and verified. When you treat segmentation as a set of enforced rules rather than a label, your thinking becomes much more accurate. It helps to connect segmentation to the scoping logic you already learned, because segmentation is not its own independent goal. Scope is driven by where card data is and what can impact it, and segmentation is one way to limit what can impact it. Imagine a small locked room inside a busy building. If only a few authorized people can enter the room and the doors are controlled and monitored, then problems elsewhere in the building are less likely to reach what is inside the room. In network terms, if the CDE is isolated and only necessary connections are allowed, then an infection on an employee laptop in the office network is less likely to become an infection inside the CDE. That isolation supports a smaller assessment scope because fewer external systems have meaningful influence. But notice what makes the analogy work. The door must actually stay locked, the keys must be controlled, and there must not be secret hallways. Segmentation only shrinks scope when those conditions are true. If there are secret paths, then the CDE is not truly isolated, and the scope may need to expand. A key beginner concept is that segmentation is not a single device or a single setting. It is the outcome of how an environment is designed and controlled. Firewalls, routing rules, access controls, and segmentation technologies can all contribute, but what matters is the result. Do outside systems have unauthorized paths into the CDE? This is why a QSA focuses on what is allowed and what is denied, and how those decisions are managed over time. A single change in a rule can open a pathway that defeats the entire segmentation claim. So segmentation is not only about architecture, it is also about ongoing control. Organizations sometimes start with strong segmentation and then weaken it gradually through convenience changes, emergency exceptions, or poorly tracked requests. A QSA who understands this will ask not only what the rules are today, but how rules are reviewed, approved, and monitored. The exam often rewards this mindset because it shows you are thinking about defensibility and sustainability, not just about an instant snapshot. To understand how segmentation shrinks scope, you need to understand what it changes about connected to systems. Without segmentation, large parts of the corporate environment might be able to communicate with the CDE, which means many systems could potentially impact CDE security. That quickly expands scope because the assessment must consider those systems as part of the security story. With strong segmentation, most of those systems are blocked from reaching the CDE, which reduces their impact. As a result, the CDE becomes a smaller island that can be assessed more directly. But there is a catch. Any system that is allowed through the segmentation boundary, even for a narrow purpose, becomes important. For example, if a logging system outside the CDE receives logs from inside it, the connection might be one way, but you still need to consider whether that connection could be abused. If an admin jump system can reach CDE servers, that jump system becomes high impact and is likely in scope. In other words, segmentation shrinks scope broadly, but concentrates attention on the few allowed bridges. That concentration is part of why segmentation is so valuable, because it makes the assessment more focused. A common misconception is that segmentation is proven by showing that a CDE network uses different IP ranges or different names. Those details can help describe the environment, but they do not prove isolation. Isolation is proven by demonstrating that unauthorized traffic cannot cross the boundary and that only explicitly permitted traffic can. Another misconception is that segmentation exists because the organization says it does, or because the architecture was designed that way years ago. The truth is that segmentation is a claim that must be validated in the current environment because real-world networks change. People add remote access, new integrations, vendor support paths, and troubleshooting shortcuts. Over time, those changes can create new routes that bypass intended controls. This is why a QSA treats segmentation validation as a current reality check rather than a historical design review. If the segmentation is real, you should be able to explain it clearly, show the controlled pathways, and demonstrate that the rest is blocked. Even though we are not doing configuration or tool work here, it is still useful to understand the types of evidence that support segmentation in principle. Evidence might include network diagrams that show boundary devices and zones, rule sets that document what is allowed, and records that show changes are controlled and reviewed. It might also include proof that testing was done to confirm that prohibited traffic is blocked. The important idea is that evidence should support both design and effectiveness. Design evidence shows what the rules are supposed to be, and effectiveness evidence shows that those rules actually stop what they are supposed to stop. Beginners sometimes focus only on design because it is easier to look at documentation than to think about how to validate real behavior. But in PCI assessment thinking, a boundary is only defensible if it can be shown to work. That is why segmentation is not just a diagram topic. It is an operational control topic. Another practical beginner insight is that segmentation is often undermined by shared services, because shared services create invisible bridges that people forget to include in the scope story. Examples include shared directory services, shared patch management, shared backups, shared monitoring, and shared administrative tools. If a shared service outside the CDE can push changes into systems inside the CDE, that service can impact security, which weakens the argument that the CDE is isolated. This does not automatically mean segmentation fails, but it does mean the scope story must account for those bridges and control them carefully. Sometimes the best approach is to place certain shared services inside the CDE or to create dedicated instances for the CDE. Other times the approach is to constrain and monitor the connections tightly. Either way, the QSA mindset is to hunt for control paths, not just data paths. If an outside system can administer a CDE system, that is a major path of influence, even if card data never travels across it. Remote access is another area that can quietly collapse segmentation if it is not handled carefully. Many organizations allow vendors or internal admins to access CDE systems remotely, and that access path can become a hidden corridor through the boundary. If remote access is available from broad corporate networks, or if the controls around it are weak, then the segmentation story is less convincing. For example, if an employee workstation can establish an administrative session into the CDE without going through controlled choke points, then that workstation can impact the CDE and may need to be in scope. A strong segmentation model typically forces remote access through tightly controlled gateways, limiting who can connect and what they can reach. Again, we are not configuring anything, but the conceptual point is that segmentation is defined by allowed paths. When remote access creates too many allowed paths, the boundary becomes porous and scope grows. Segmentation also has a human side, because people can weaken boundaries through convenience decisions and workarounds. If teams do not understand why segmentation matters, they may request exceptions constantly, and those exceptions add up. If change management is weak, rules can be modified without proper review, creating unknown access paths. If documentation is not kept current, the organization can believe segmentation exists while the network has drifted into a different reality. This is why a QSA thinks about governance and process alongside technical separation. A boundary is maintained by rules and by the discipline around those rules. When a QSA evaluates segmentation, they are really evaluating whether the organization can sustain the separation over time. This is also why segmentation questions on exams often include elements about documentation, validation, and ongoing control. The correct answer usually reflects a complete mindset, not just a one-time design decision. To wrap up, using network segmentation to shrink scope dramatically is about creating and maintaining real isolation between the CDE and the broader environment so that only controlled, necessary connections exist. Segmentation shrinks scope because it reduces the number of systems that can impact CDE security, but it also makes the remaining allowed bridges much more important to evaluate. A QSA does not accept segmentation claims based on names, diagrams, or past design intent, because segmentation must be validated as current reality. Effective segmentation is supported by evidence of design and evidence of effectiveness, and it must account for shared services, administrative paths, and remote access corridors that can bypass boundaries. When segmentation is done well, it makes both security and compliance more manageable because it focuses protection and assessment effort where card data truly lives. When it is done poorly, it creates a false sense of safety and leads to scoping mistakes that can undermine the entire assessment. Understanding this balance is a major step toward thinking like a confident QSA.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.